In this video, you will learn how to factor some quadratics, specifically ones where the constant a in ax squared plus bx plus c is not equal to 1. For example, how would you factor 2x squared minus 3x minus 5? It's different than factoring something like x squared minus 5x minus 6, because in the first example, there's a coefficient in front of x squared. So how do we factor when there's a coefficient in front of x squared? First, let's look at something a little different. How do you multiply binomials? Well, you multiply the first terms, the outer terms, the inner terms, and then the last terms. This is the same way you would find the area of a rectangle if the sides were two binomials. So in this example, the top of the rectangle has length ax plus b, which is the first binomial, and it has height cx plus d, which is the second binomial. To find the total area of the rectangle, you'd find the base times height of each small rectangle and then add them all together. You would see that the answer is the same for either approach. So back to the original question, how do we factor something like 2x squared minus 3x minus 5 into two binomials? Well, if we could put each term into its corresponding box, then we could work backwards and figure out the two binomials. But we have a problem. The front term over here is made by multiplying the two first terms, so we can put it in that box. And the final term over here is made by multiplying the two last terms, so we can put it in that box. But where does the middle term go? The middle term is made by multiplying the two x term boxes. So we know ADX plus CBX is equal to negative 3x, or if we divide by x, AD plus CB is equal to minus 3. But this is not enough information to figure out what AD is or what CB is, so we'll have to find one more relationship between the two terms. So what's the second relationship? The second relationship is AD times CB. But what does AD times CB equal? Well, if you look back at the box in variable form, AD times CB is equal to AC times BD. They're both equal to ABCD. And we know that AC times BD is equal to 2 times negative 5, or negative 10, which means that AD times CB must also be negative 10. So what two numbers add up to negative 3, and when multiplied are equal to negative 10? Well, negative 5 plus 2 is equal to negative 3, and negative 5 times 2 is equal to negative 10. So now we put negative 5 and 2 in the remaining boxes, remembering that they're x term boxes, so each term gets an x. Now we have 2x squared plus 2x minus 5x minus 5, which can be factored by grouping. If we separate it like this, then each part can be factored. This part has the greatest common factor of 2x, so we take that out and we're left with 2x times x plus 1. And this part has the greatest common factor of negative 5, so we take that out and we get minus 5 times x plus 1. Now our new expression is 2x times x plus 1 plus negative 5 times x plus 1. This has the greatest common factor of x plus 1, so if we pull that out, we are left with x plus 1 times 2x minus 5. This is the final answer. 2x squared minus 3x minus 5 in factored form is x plus 1 times 2x minus 5. I think this will all make much more sense after doing some examples. Examples. The first example is, what is 12x squared plus 5x minus 2 in factored form? This time I won't explain each step, so it should take less time, and although it may seem different, each step will be the same as before. So to factor 12x squared plus 5x minus 2, we must replace the 5x with two x terms. I will label them ax and bx. A times b, we know, is the first term times the last term, which is 12 times negative 2, or negative 24. And we know a plus b is equal to the middle term, which is 5. So what two numbers have a product of negative 24 and a sum of 5? Well, 8 times negative 3 is negative 24, and 8 plus negative 3 is 5. So we replace the a's and b's with 8 and negative 3, giving us 12x squared plus 8x minus 3x minus 2. Next, we factor by grouping, and break this up into 12x squared plus 8x plus negative 3x minus 2. Then we take out the greatest common factor on both sides. 12x squared plus 8x has the greatest common factor of 4x, so we take that out, and negative 3x minus 2 has the greatest common factor of negative 1, so we take that out as well. Now 4x times 3x plus 2 plus negative 1 times 3x plus 2 has the greatest common factor of 3x plus 2. And if we take that out, we are left with 3x plus 2 times 4x minus 1, which is the final answer. 12x squared plus 5x minus 2 in factored form is 3x plus 2 times 4x minus 1. The next example asks, when is 2x squared minus 8x plus 6 equal to 0? Well, one benefit of having a function in its factored form is that solving problems like this one can become much easier. So let's factor 2x squared minus 8x plus 6. First, we replace the minus 8x with two different x term numbers, where a times b is equal to 2 times 6, or 12, and a plus b is equal to negative 8. Negative 6 and negative 2 match this description, with negative 6 times negative 2 equal to 12, and negative 6 plus negative 2 is equal to negative 8. So we replace the a's and the b's with negative 6 and negative 2, giving us 2x squared minus 6x minus 2x plus 6. Now we factor by grouping. First, separate, then take the greatest common factor out of each group. We take 2x out on this side, and negative 2 out on this side. Finally, we separate once more by taking out x minus 3, and we get 2x minus 2 times x minus 3. This is not the final answer because it asks, when is this equal to 0? Well, if the whole expression is equal to 0, then either 2x minus 2 is equal to 0, or x minus 3 is equal to 0. Now we solve. 2x minus 2 is equal to 0, add 2 on both sides, and then divide by 2 on both sides, which gives us x is equal to 1. And for x minus 3 is equal to 0, we add 3 on both sides, leaving us with x is equal to 3. So this problem has two answers, 1 and 3. This makes sense because 2x squared minus 8x plus 6 when graphed looks like this. And as you can see, it is equal to 0 both at x is equal to 1 and x is equal to 3.